Hey guys, it's Harmon here. Um, Glad everyone's here today. So this is going to be our digital lesson on linear functions. Now, our goal today is to reinforce how to create linear functions from tables and situations. That's something we have been working on. That's something we've shown that we are able to do. Okay, we've assessed it. We're working on figuring that out and proving that we know how to do it. That's something we have been doing. Okay, but we're also going to introduce a new concept today um, in kind of interpreting a graph, and it's to introduce the concept of domain and range. And domain and range is a way of just kind of looking at what makes sense in an equation, what makes sense, and where does it exist. And hopefully, you're going to get to discover that concept today, and you can walk away today knowing how to do that and being able to prove you can do that. All right. Um, Before we hop into the part where y'all are going to have to do the work, I did feel like it would be intelligent to kind of review the key concepts. That way, you're set up to have success in today. Okay, so I want you to create equations to represent these. Now, another thing doesn't say it on here. Right now, I want you to always label what things are. Okay, it's fantastic if you can create an equation, but if you don't know what it means and then you're not able to use it, and it kind of loses its value. All right. So A right here. So Amy has $500 and spends 50 a day. So every linear function, regardless of what's in, it really comes down to what does it start with and what does it change by? Okay. So in this particular case, I know what you're thinking. That handwriting's awesome. Okay. But in this particular case, how much does Amy have to start? 500. That's right. So she has 500. Now, we don't put the x with that. We don't put the x with that because it's not changing by 500. This is a set amount. This is what she has. Okay. Next, she spends 50 a day. So if she spends, is it going up or down? Down. We're losing 50 a day. Okay. Now, this is what it's changing by, so that's what's with x. Okay. Now, a couple ways you can write it, but I'm always a big fan of just kind of labeling in here. So I lose 50 a day. So x is number of days. Now, I know a lot of y'all will probably just put days here, and I wouldn't count that off. But be careful because I've seen people get confused with that. I want you to realize that's your number of days that you plug in, and then y is going to be the other factor here, which is the money left or money remaining. Okay, money remaining or money left. Let's go left. All right, I'm gonna have to get better at that. All right, so that's from words. All right, let's go to tables. Okay, tables. Now this is days and moose population. Okay, so same situation. What do I start with? What do I change by? All right, so in this particular case, at day 0, so when I start, I have 1,000. So 1,000 is what we start with. And in this case, in one day, I went up by 200. So since I'm going up, it's plus 200x. Okay, same concept as last time. X is number of days. Number of days. And Y is going to be your moose population. Okay, now I do want to make this point because this is something that people kind of get confused about. So some of y'all may be sitting at home and saying, well, I put Y equals 200x plus 1,000. All right, which one of these two would be correct? You're right. It's both of them. Good for you. Okay. All right. Now, it doesn't really matter which one goes first. Similarly, this one up here could have been negative 50x plus 500. Um, a lot of people prefer it this way. A lot of teachers prefer it that way. I like it this way because I'm thinking of what do I start with? What do I change by? That's an easier realm for me to think, but you do you. All right. Okay. So we're getting into our post problem part of today. So on your paper, okay, you can see number one, A through D. It's going to look a lot like this. Okay, these four problems. Okay, it's about a giant game of hide and seek at Lakeside. Okay, now here's the thing about this. Here's what I want you to do. This is a best effort exercise, like all of our things. Guys, it's okay to be wrong. It's okay to make mistakes. It's okay to struggle through this. All I'm asking you to do is to struggle through this, okay, to think about it, to really kind of put your effort into it. Sorry. Now, if you want, I do think it's healthy to set a timer, about 12 minutes for this. Now, if it comes to 12 minutes and you're not done and you want to keep working, go for it. But if at 12 minutes and you've worked your hardest and you just are not done, can't figure it out, you've struggled through it, you've put answers down, go ahead, look at the solution, look at the answers, and see if you can figure out from the explanation, and then you see if you can answer the next one. Okay, but this is an effort exercise. Okay, so I now want you to pause the video and try number one, A through D. Okay, when you are done, play the video to hear an explanation on how this problem is done. Again, you only resume the video after you have completed the problem. Okay, you may begin problem number one. Okay, so if you're back with us, that means that you have completed problem number one, A through D, or at least put in a 12-minute effort to that. And we're going to kind of go through how to do that problem and kind of just explain the key concepts of it. Okay, so this problem at Lakeside Junior High, there was an enormous game of hide and seek. The table below represents the amount of people not found after X number of minutes until everyone's found. Okay, so create an equation and label the variables. So just like we did on the practice, it's what you start with and what you change by. So in this case, you start with at minute 0, you have 160 hiders. So that's how many people we had to start in this game. And yes, I do think this would be pretty awesome to do. But that's also off topic. Now, in this case, every 1 minute, okay, because remember your change what happens in 1 minute or 1 year or 1 second or whatever. But in 1 minute, I am losing 20 hiders. So minus 20x. Okay. Now, I will see a fair amount of y'all on quizzes and such. Put X, Y. If you've shown to me that you are very competent at this, I'm not going to be a jerk and count that off. But I do like you labeling minute, number of minutes, and number of hiders remaining. But it is what it is. So that's how we create an equation. Okay. Now, if I want to know how many hiders there were after 6 minutes, I could either look at the table, or I could plug in 6 for x. 6 times 20 is 120. 160 minus 120 is 40. Okay. So that's kind of the purpose of that equation, is to be able to answer questions about the graph when you don't have all of this right here. Especially like if I want to know how many hiders there were after 3.5 minutes, then the equation would be a really good way to be able to figure that out. Okay. Now, that's what's the thing we have been working on. Okay, that's the thing we have been working on. Now, this next concept right here gets really interesting. Okay, it's domain and range. Okay, now Here's what one thing you really need to realize in this problem for it to make sense is this is set up to hopefully allow you to realize a trick. And as you go down, okay, everything makes sense, but then all of the sudden we get here. Now, it says after 9 minutes, you'll have negative 20 hiders. Does that make any sense at all? No, it doesn't. You can't have a negative 20 hiders. You can't get so caught up in math world that you don't realize what's happening in the context of the problem. So this part right here, this part on the graph actually answers question D. Is there a point on the table that does not make sense in the context of the problem? Yeah. At 9, negative 20, okay, that doesn't make sense because you cannot have negative 20 hiders. That's ridiculous. Doesn't make any sense. Okay. Now, you are able to kind of figure out these first two parts based off of it. So domain is x, and x in this case is minutes. So when you're doing domain, you have to think, where does this start making sense? When does it stop making sense? So where it's going to start making sense is almost always at minute 0. You really can't have negative time. It doesn't really work like that. So it starts at 0. This is where it starts. Okay, and this is how you write domain and range. It's called an interval. Okay, from blank to blank. So it starts at 0. Okay, all right, it makes sense. 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 It doesn't make sense down here. So at what minute do I run out of people and this stop making sense? That's right, at minute 8. So domain is x, okay? So it means when does this start making sense? When does this stop making sense? Domain is x, okay? Domain x. All right, range is y. In this case, y is hiders remaining. So you always write this from smallest to biggest. So you think in the context of this problem, what is the least amount of hiders you can have? Because that's your y. What's the most? In this case, 0 is the least amount of hiders I can have. Okay? And the most amount of hiders I can have is 160 because that's what I started with. Now, anywhere in between 0 and 160 is going to make sense. So that's how you write the domain. That's how you write the range. Domain and range. Domain x, range y. I actually have a fantastic dance about that, but another time, another place where I'm not being recorded. So that's essentially just kind of how that works. It's domain is x and range is y. Okay, now I want you to look at the second page in here, and we're going to see attempt number 2, A through E. Now, this is number 2, A through E on your paper, okay? If you want to complete it on your own paper, that's perfectly okay. If you want to type it in here, that's perfectly okay. Just kind of whatever your dearest heart, decides to do. This is going to be about Lakeside Student Council is hosting a Glow in Their Dance, and they're handing out glow sticks. Okay, it's a little bit of an interesting problem because you can't see the whole thing. On this past problem, you could really see the whole scenario. So in this one, you're going to have to do a little bit of algebra to kind of figure out some things. Okay, same protocol as last time, guys. Here's the deal: if you just watch it, if you just watch the answer, you're not going to struggle. I need you to struggle and think. That's the whole point of all of this, is you're able to struggle and think and persevere. And then even if you don't get it, even if you don't figure it out, then that attempt is going to make you get stronger. All right. So I want you to try your very, very best on here. Same protocol as last time. Set a timer for 12 minutes. If you're not done at the end of 12, you're welcome to watch the answer and see if you can figure it out. Okay. So at this point, again, I want you to go ahead and pause the video when I'm done talking here. You're going to pause it, and then I want you to attempt number 2, A through E, for at least 12 minutes. If you want to keep going, if you're not done, you most certainly can. Or if you get done early, then you're allowed to watch the video. Um, Try your best effort and really just take some pride in trying to figure this out. And you can resume the video when you're done with the question. Okay? So you may attempt number 2, go. All right, guys, we're back. So hopefully you had enough time that you were able to make a good attempt at number 2. Okay, so let's just kind of run through this and really see what we're made of. So create an equation to represent this scenario. So again, linear functions are always what you start with, what do you change by. If you're getting annoyed hearing me for that, I really, truly hope that you have dreams of me saying that so that you will never, ever forget it. It's what you start with and what you change by. That's how you're able to create most linear functions, at least in this form. Okay? So I think this is about glow sticks and people. All right? So how many glow sticks do I have to start? That's right, we have 500. Okay? And then I'm losing 3 for every person. Now in this case, X, I have to label X and Y always. Okay, so X, I lose 3 a person, so X is my number of people. Number of peeps, which I think is short for people. I'm not really good at lingo. Okay. All right, and then Y, this whole problem is about glow sticks, is number of glow sticks remaining. Glow remaining. Not proud of my handwriting, guys. Really kind of a weak point in my life. Okay. All right. Very good. Okay, now we're going to go into domain and range. Now, let's recall this. So domain is the X values. Domain X, range Y. Now, so domain is X, and X in this case is people, is the peeps. So, what I need to know is what are the least number of people that could come into the dance, and what's the most number of people to come into the dance. So in this case, the least number of people that could come in, this number is like almost always 0 in context problems. Okay, not always, but like 98% of the time. So that's what we start with. That's the least number of people that could come in. Now, the most number of people that can come in is when I run out of glow sticks. So a couple ways you can go about this, but the easiest way is just thinking, okay, I need to know when I run out of people. And this will be when I run out of glow sticks. So I run out of glow sticks when my Y is at 0. Okay, so 500 minus 3x. Now I just kind of have to solve for x, so minus 500 from both sides, then divide by negative 3. So kind of went fast there. So you minus 500 from both sides, and you get negative 500 equals negative 3x. To get x by itself, you divide by negative 3. Remember the opposites until we get that variable by itself. And if we do 500, negative 500 divided by negative 3, we get 166.66. Okay. Now, this is interesting because most people write this right there. But why does that not make sense? Yeah, you can't have 0.66 people. So, you kind of have options here. You can either say, now, what makes the most sense is explain what you're saying. I think at 166, that's the most that can come and get glow sticks and get the 3 glow sticks. I've seen people on this problem write 167 and they gave the last person 2 glow sticks, like something like that, and that's perfectly okay. Guys, what I'm looking for is understanding of what's happening. So if you're able to explain what's happening, then good for you. Okay? You're good. All right, now y in this case is glow sticks, and this one's actually a little easier here. What's the least number of glow sticks I can have is 0. That's correct. And the most number of glow sticks I can have is 500, which is what I started with. Okay. Usually, either domain or range, one of them is usually pretty easy, and then one of them you have to solve for, is usually how that works. Okay. Um, good. Now, D and E are plug-in work problems. There are 89 glow sticks left. How many students are at the dance? So 89 glow sticks. Glow sticks is Y. So into my equation, I just plug in 89. Right? 500 minus 3x. And then at that point, I'm minus 500 from both sides. So 89 minus 500. Okay, and then divide by -3, and I'll get 137. Okay, that's the most number of people. That's the number of people that could go. And then if there are 120 students at the desk, how many glow sticks will they have? So students is X here. So I would just plug in 122 for X. In this case, this is kind of the easier of the two problems for most people. So I just plug that, I just do 3 times 122, and then I think that's 366. So 500 minus 366, and we're going to get 134. Okay. Now I know there were some working pieces here, but as long as you gave your best effort, and hopefully this made sense. If not, feel free to contact me and we can talk about it. That's how this problem is done. Okay. Now at this point, I want to know where we are. Okay, where are we at in this? So here's what I want you to do. We should go back to Google Classroom, okay? And in Google Classroom, located directly below your work, your sheet for today, your post problem that had this video in it, um, there is a assignment named linear equation formative. It is going to be a one problem thing where you're just going to be making an equation and telling me the domain and range. What I want you to do is I want you to complete your work on a sheet of paper, take a picture of it with your Chromebook, which we've taught you how to do, and then paste that picture on the quiz and then upload it to Google Classroom. Okay. If you want to just write it in the thing and explain your work, you are welcome to. But if you want to show your work, where it kind of gives you more the option of partial credit, then I do recommend that you take the video and upload it into it and then share it with me. Try your best effort on it and know that we're going to be here to support you and let y'all and allow y'all to have success in this as going forward. Guys, thank y'all for listening today. If you have any questions, feel free to email me. And make sure you complete that formative assessment right after this. Have a great day. Thank y'all.